Welcome back to B Spice. In this session, we'll continue with OT cybersecurity and we'll talk about the defense in depth architecture capabilities. This is, in fact, the part two of defense in depth of architecture capabilities. So, this session is more on the network security. Okay. So, if you remember, friends, previous session we talked about the layer one security management and layer two physical security. So this session is exclusively for layer 3 network security, and of course we'll be covering layer 4 and layer 5 in the latest sessions, right? So yeah, when we talk about the layer 3 network security, let's talk about the network architecture. A good practice for network architecture is to characterize, segment, and isolate and IT and OT devices. Is it? So I don't know whether you have gone through my previous sessions. I mean, long back we talked about the zones and conduits, right? I just want to touch upon a bit for the benefit of first time viewer. Zones and conduits are the key concepts in the industrial cybersecurity used to segment and secure the control system. Zones are group of assets with similar security needs. Say, for example, as you can see here, BCPS, SIS, these are all the zones, and the conduits manage the communication between this. That's the meaning of it. Okay. For example, the devices may be segmented based on the management authority, level of trust, functional criticality, data flow, location, or other logical combinations. Right. So organization may also consider using an industry recognized model to organize their OT network segmentation, such as Purdue model. This is the one look and feel of the Purdue model. As you can see here, the devices all from level 0, then level 1 talks about the controller, level 2 talks about the HMI, level 3 talks about the control operations, and we have a DMZ at 3.5, and we have a level 4 business and planning and logistics, and level 5 we have a enterprise. In fact, a separate video on this Purdue model was uploaded in our BSpy channel. You can also watch if you're really interested. Okay. So that's a point actually. Organization may consider using an industry recognized model to organize their OT networks such as Purdue, ISA 9562443, and of course the tier 2, sorry, 3 tier, what do you call, IIoT system architecture, or any of the combination of this. Okay. So yeah, that's about the architecture. It's like a basic introduction. And additionally, I want to talk about this organization. We can also incorporate a DMZ, actually a demilitarized zone, as an enforcement boundary between the network segments as shown here. That's a point here, right? Okay, so let's get move on with this, the network security. Implementing network segmentation utilizing the levels, tiers, zones allows organization to control access to sensitive information and components while considering operational performance and safety. Network devices that support traffic enforcement capabilities, whether it's a switches, routers, firewalls, and unidirectional gateways or data diodes, can be used to implement network segmentation and isolation. Friends, this unidirectional gateway is nothing but it can only communicate, one way actually. So the other guy has to respond. I mean, allow, then only you can go, you can get the response. So it's basically a unidirectional, passing of data. So firewalls are commonly used to support network isolation, employed as a boundary protection devices to control connections and information flow between the network segments. So these are the aspects we should focus as part of the network security layer 3. To continue further, firewalls may be deployed as network devices or directly on some host. Firewalls are very flexible isolation device and typically constitute the primary mechanism for protecting the OT device. Appropriate firewall configuration is essential to properly securing the network segments. Firewall rule set should be established to permit only the connection between adjacent level tiers or zones. For example, organizations that utilize this model, Purdue model architecture, to implement firewall rules and connections that prevent this guy L4, directly communicating with L2, 1, all these levels. Okay, you got it, friends? Yes. So a similar concept would be applied to the ISA, IEC 62443 and 2Z architecture as well. Okay. So this is all about the network security. Yes, to add on few more. One area of considerable variation in practice associated with the firewalls in the control of outbound traffic from the control network. So you may be asking or wondering what is this outbound, traffic, right? So outbound traffic is nothing but the data flows out of the network or the system to external destinations such as the internet or another network. Okay. So basically it's an opposite of inbound traffic, okay, which enters the network. So this is basically flows out of the network. So allowing outboard connection from lower level tiers or zones could represent a significant risk if unmanaged. So organizations should consider making outbound rules as stringent as inbound rules to reduce this risk. An alternative to firewall is unidirectional gateway or data diode that permits authorized communication in only one direction. That's what I mentioned earlier. It allows only one direction. So the use of unidirectional gateway may provide additional protections associated with system compromises at higher levels or tiers within the environment. For example, a unidirectional gateway deployed between the layers 2 and 3, and this may protect layer 0, 1 and 2 devices from cybersecurity even that occurs at layers 3, 4, 5. Okay, that's the point. I repeat once again. For example, a unidirectional gateway deployed between the layer 2 and 3 may protect layer 0, 1, 2 devices from cybersecurity event that occurs from level 4, 3, 4, 5. Okay, so that's the point here. Right. So now we talk about the centralized logging. Network computing devices such as routers, gateways, switches, firewalls, server workstations should be configured to log events to support monitoring, alerting, and incident response analysis. Logging capabilities are typically available for recording events in applications, OS, and network communications. A centralized log management platform is a must and it can assist organizations in supporting log retention, monitoring and analysis efforts. This is about the central logging as simple as it, right? Yes. Then we talk about the network monitoring. Network monitoring involves reviewing alerts and logs and analyzing them for signs of possible cybersecurity incidents. Basically, we are monitoring the complete network here. Tools and capabilities to support the behavior of anomaly detection, that is a bad signal or bad data, security information and event management, SIEM. This also we have already uploaded exclusive video in BSpice. If you are interested, you can watch and get benefited. And additionally, we have an intrusion detection system, IDS, and intrusion prevention system, IPS, which can assist the organization with monitoring traffic through the network and generate alarms when they identify anomalous or suspicious traffic. OT system traffic is typically more deterministic, meaning repeatable, predictable, and designed than the IT network traffic, so which can leverage to support network monitoring for anomaly and error detection. Implementing networking monitoring in a passive, meaning listen or learning mode, and analyzing the information to differentiate between the known and unknown communication may be necessary first step in implementing network security monitoring. So that's the point. Okay. So that's about the network monitoring. Few more to add on. Organizations should consider the effects of encrypted network communication on their network monitoring capabilities and deployment strategy. Encrypted network communication, meaning it's not easy to understand actually, right? So for example, a bad system or IDS may be unable to determine whether the encrypted communication is malicious and cloud generate false positive or negative alerts on the traffic. I repeat again, for example, a bad system or IDS may be unable to determine whether encrypted network communication is malicious and cloud generate false positive or negative alerts on the traffic. So what I meant here is organization should consider the effects of encrypted network communication on the network monitoring capabilities. Changing the data collection point to capture network traffic before and after encryption. Using a host-based network monitoring tools could help to improve the monitoring capabilities when encrypted communication is expected. I'm not sure whether you are following this, friends. See, basically, there are a lot of jargons here actually. See, I talked here about what do you call the changing the data collection point to capture network traffic before or after encryption using a host-based network monitoring tool. So what is this host-based network monitoring tools? See, host-based, it's basically security involves installing security software directly on the individual devices, that is host, such as servers or desktops or laptops actually. For example, antivirus software and host-based firewalls, intrusion detection system, all these actually. It protects a single device basically. That's a point, right? Okay. So yeah, that is about the host based, and also the network. If it is network based, means it is it protects the entire network by analyzing the traffic that flows between the devices, meaning the network firewalls, intrusion detection device systems, and packet sniffers. All these actually. So basically, the network based security covers all devices connected to the network. You got it, friends? Yes. So IDS, IPS, intrusion detection, intrusion protection system products are effectively, effective at detecting and preventing well-known internet attacks. And some IDS and IPS vendors have incorporated attack signatures for various IT protocols such as Modbus, DNP3, that is Distributed Network Protocol 3, and Inter-Control Center Communication Protocol, ICCP. So again, you may be wondering, what is this DNP3? So DNP3 is nothing but, distributed network protocol version 3 is a communication protocol used primarily in industrial automation and SCADA systems to enable the reliable data exchange between the control center and the field devices. So basically, this guy, the DNP3, was designed to facilitate communication between SCADA master station, remote terminal units, and intelligent electronic devices in electric utility system. So that's the thing actually. It is built to operate in harsh environment with poor transmission media and electromagnetic interference. This makes it ideal for long distance and mission critical infrastructure. That's the point about the DNP3. Then we have, this ICCP protocol. What is this ICCP protocol? ICCP is nothing but the Inter-Control Center Communication Protocol. We also call it as TAS2, TASE2, or IEC 60870 Part 6 is a standardized protocol used to, secure and reliable data exchange between control centers in electric power systems. So this ICCP was developed to meet the need for real-time communication between utility control centers, regional transmission organization, and independent system operators and other entities involved in the power grid operations. So that's the meaning of this actually. So the point is, we should also have, incorporate the attack signature for various products here. Okay, so now to continue with network monitoring, an effective IDS IPS deployment typically involves both host-based and network-based capabilities, which I already talked. Host-based, what is host-based, and network-based. Okay, so yeah, I don't know whether you're following or not. So yeah, that's a point. What is host-based again? Want to repeat me? I'll repeat actually. Say host-based is nothing but involves security directly. It's a security software directly on the individual devices, such as servers, desktops, or laptops. Network-based monitors and protects the entire network by analyzing the flows between the devices. Then organization should consider the impact that automated response associated with IPS may have on the OT environment before deploying. In some cases, organization may consider placing IPS units at higher levels in the environment. That's a DMZ interface to minimize the potential issues with automated responses impacting OT. In OT environments, network-based monitoring capabilities are typically deployed on boundary protection devices using switch port analyzer ports or passive network tap. I don't know whether they're following again, ISPN. It's basically a switch port analyzer. Okay. Yeah. So again, a switch to port analyzer span is a network monitoring feature that allows a switch to copy traffic from one or more ports and send it to another port where a network analyzer is connected. It's commonly used for troubleshooting, performance, and monitoring and security analysis. Okay. So basically, this guy span enables administrators to observe network traffic without interfering with it. That is the point. Okay. Organizations should also consider deploying host-based monitoring capabilities on compatible OT devices, such as HMIs, SCADA servers, engineering workstations, to improve monitoring capabilities, provided that the addition of tool does not adversely impact the operational performance or safety. So that's all I have for this layer 3 network security, friends. Of course, I'm going to continue in the defense in-depth architecture capabilities in the next session also, wherein I'm going to talk about the very big thing, a zero trust architecture, ZTA. Stay tuned. Thank you. Take care. Bye.